This is Professor Derf Seitz. This Java tutorial demonstrates the queue data structure using the Java class library ArrayDeque class. A queue is a first in, first out data structure. You can think of it as a line of people waiting to use something. Could be an ATM or waiting in line at a bank to buy a ticket, whatever. There's a front to the line, the next person to be serviced, and a rear to the line where new arrivals go. So in terms of the queue, the front is the position where items are deleted from the queue. That's where they're serviced. They come off the queue to be serviced. And there's a back where they're added. And in terms of operations, the add operation is what adds an item to the back of the queue, and the remove operation is what takes an item and deletes it from the front of a queue. There are alternate names. For the front is also known as the head, the back is also known as the tail, the rear, or the end. Add is sometimes called insert, and remove, delete. Here's a picture of a little queue where the front right here is the 55 and the back is the 23. So the 55 is the front end where things will be removed. They're the next to be serviced, and new arrivals go on the back here. So the ones that are in first, they've been in the line the longest, they're going to come out first. We have a class called QDemo, and inside there we have a private data member, an ArrayDeque, which is an implementer of a queue, of the queue interface. And we call it our object queue. And generics, we're using an integer element type, a wrapper class. The main method instantiates the class and calls these test functions on it. First, we're going to test adding items. We add these items to the queue one by one, and then we're going to annotate the output. Next, test removing items from the queue. Remove 3 items in a row. There are 2 methods to remove all. This first one uses a while loop. While the queue is empty, returns false. It means there's still items in the queue. We'll continue to remove them. When it returns true, then we're done removing things. An easier way to remove all items is through the queue clear method right here. Here we're going to test the first in, first out characteristics of a queue. We have a local queue here with the same name. It's going to hide the other queue from sight. And this queue uses strings as the generic type. We will add first in, first out, 4 different strings to our queue. And the first one we added was first, so we have a note here that that's the first in. Then we display the queue and then start removing items. So the first one removed will be right here, and we'll see in the output that the first in should be the first out. Since a queue is iterable, you can use a for each loop on it, and here's a for each loop that iterates through the queue to print out each entry. Finally, this is a helper function used in some of the other functions to initialize the queue to its starting set of values by clearing it and then adding these integers in there. Let's run this and examine the output. First, in the output, we add the items to the queue. Here are the items. The front is annotated here on the left and the back on the right. The square brackets and the comma separated list came from the toString function of the ArrayDeque, and we see that we have our little queue there. Then we're going to remove 3 items from the queue. They're going to come off the front. So the 55, the 18, and the 5 come off, leaving us with a new front of 100. 2 remove all functions give us an empty queue. This one initialized the queue back after it being empty, and then did the clear function to remove everything. Here's the first in, first out test. We add first, that's the first in. Add in, first, and out. Here's the queue now, with that front is first, and out in the back. And then we remove, and the first thing to be removed is the first, that's the first out. So the first in, which is the one that was the longest in the line in the queue, is the first one out. Here's the iterator to iterate through the queue, and it iterates from the front towards the back. And again, that would not be a standard function for a queue. It's something available because of the inheritance implementation hierarchy, and it does allow us to do this for whatever purposes we may have, but it does go against the grain of what the queue is supposed to be fundamentally able to do. Let's go back to the program code now. So we understand now a little better about the queue data structure after seeing it visually in the output, how it works. And it's very easy to use it by using the collection framework, in this case the ArrayDeque serving as our queue object.